So here is our first Excel application, finance application in Excel. This is the first video I'm doing to work you through how to use Excel to do really pretty practical financial equations. Here we're dealing with the time value of money. If you've been through the modules for this class and have looked at the class notes, you notice we're dealing with problems that are present value problems and problems that are future value problems. Sometimes it's just one number we're calculating. Sometimes we're calculating several numbers over time. So let's look at these formulas. These are the formulas we say you should know. The first four, you should just know them. The last two, I would not bother to memorize those, but we are going to build them into Excel so that we can use them over and over again depending on the problem. So this is the very first problem. You'll notice how I'm going to do these sessions is each session will have multiple problems. I'll work the first one or two problems, usually just the first one here. I'm going to work the first two because one is a future value problem and the second one is a present value problem. So I want to get you both examples and then you can work through the other examples because you'll have the format built. So let's look at the formulas that we need to know. Now the first one says that the present value, what something is worth today, will be what it's worth in the future divided by 1 plus an interest rate, I, raised to the time, n. We will actually rarely use this formula in this class. You will not use it ever in the Excel applications. There really are not that many good applications for this. We'll much more use number 3 than we will use number 1 because most of the things we're going to value for in today's terms have multiple future values, not just one. So we'll see that when we value stocks and bonds, but in this case we just will not use that formula very much. The second formula we're actually going to use in this first problem, and this is if you're trying to forecast something. You know what it's worth today, the present value, but you want to forecast what you think it will be worth in the future, a future value. So that future value forecast is the present value, what it's worth today, times 1 plus a rate, I, raised at the time, n. Usually the I here is maybe inflation. So in this first example, we know what a car is worth today in today's dollars. We're trying to forecast what we think that car is going to cost in the future. So we'll multiply it out with this formula for an inflation rate. Some assumption, we won't be exactly right, but some assumption that'll get us in the ballpark of what something's worth in the future. This is the only problem. This first problem is the only one we use this formula for, but I want you to get some exposure to it because it is an important concept. And it's actually something you'll probably use in your team case for the cost-benefit analysis where you'll be forecasting something in the future at some future value using inflation as your input. The next one we're going to use in our second problem, and it says that the present value of something equals whatever payments you're making times the present value interest factor of annuity, formula number 5. Now we probably won't use this formula as much as we will use this algebraically similar formula, exactly the same formula actually, that says the payment you're going to make. Here we're talking about loan payments usually. Your loan payment will equal whatever the price of the car is that you're buying divided by that present value interest factor of an annuity. So we'll use this when we're doing loan schedules, loan amortization schedules. We'll use this in the second problem. In the first problem, we're going to use this future value problem. It says that the future value of something equals whatever investment we make, whether that's monthly or weekly or whatever, times a future value interest factor. Or we may actually be trying to figure out how much investment do I need to make in order to get to some future value. And we'll do that by taking the future value, that target portfolio, maybe it's when we retire. How much money do we need when we retire so that we can retire comfortably? So the investments we need to start making today equals that future value divided by the future value interest factor. So we use that quite a bit. The present value and future value formulas, here they are. They look a little complex, but they're really not that bad at all, especially once you get them set up in Excel and you can just reuse them. So that's what we're going to do. We're going to set them up. All right, so what you need to do, and this is our first experience with this, so you'll see how I do this. You don't necessarily need to put the problem up top, But what I'd encourage you when you do your Excel is to create your own format, your own color coding, so that I see every time I bring up one of your exercises, I see your unique signature, what colors you like, what formatting you like, make it look professional. So you can put the problem in the first one. Essentially what I did is I combined all of these cells. If you want to do that, it's actually not too difficult to do. You hit your shift button and you hit your arrow keys, and you can just select a bunch of cells together. And if you do the Alt key while holding down the Alt key and type the letters H, M, and C, it will combine all of those cells together, and you can do what I did up top. So you don't need to do that, but it is something that you can do. So that's what I did here, is I combined all these cells together, all on row 1, and then I just stretched out row 1 and I format it. But if you want to do that, that's fine. You don't have to do that. You can just leave that cell A1 and all this blank, but make sure the next cell you start in is cell A3. You also don't need these formulas over there, so you just need to go to A3, and we're going to start typing. And what we're going to put in A3, in the first cell, we're going to put our rate. That's the I in the formula. In A4, we're going to put time. That is the N in the formula. The next one is going to be our target, whether it's that present value or that future value that we're looking for. In the next cell, we're going to put our present value interest factor of an annuity. We're going to put that formula in. In A7, we're going to do the future value interest factor of an annuity. Now, this first problem is a future value problem, but I want you to put the present value interest factor of an annuity and the future value interest factor of an annuity in all of your applications, so that whichever one you need, you have it there and ready to use. All right, so let's start with this problem. The first formula we're going to put in is the I, the rate. So when you look at this problem, Tobe has this problem. He has this great idea. It's actually something I do in my own personal life. I think it's a great idea. I tell my undergraduate students to do this. So let's say he buys a car generally every 5 years, but he wants to get one car to last him 10 years. He's just going to run that car into the ground. In the first 5 years, he'll make his loan payments. The second 5 years, he'll keep making his loan payments, but instead of making them to the bank, he'll make them to himself in an investment account, so that at the end of 10 years, when that car wears out and he turns it in, he can then take what he saved years 6 through 10, and he can start buying cars with cash. And then for the rest of his life, instead of making payments to his bank or his credit union, he'll just put those in investment accounts, and he'll just be buying cars with cash the rest of his life. So rather than paying the bank interest, he'll earn interest himself. And he thinks he can make 6.24%, but he's going to invest weekly. So the I, what we're going to do is to do equal 6.24%, but we have to put it in terms of how he's investing. So you want to take your I and divide it by how many times he's going to invest every year. So here he's investing weekly. There are 52 weeks in a year, so he's going to divide by 52. If he were investing monthly, he would divide by 12. But he's investing weekly, so he's going to divide by 52. When you put that in there, I want to change the format. You can change the format by either right-clicking and clicking on Format Cells, or what I prefer is go up here and actually click on the percent sign, and then over here on decimals, go 2 decimal places. Either way is fine. So what you'll see when I do these Excel applications, I will put the formula next to the cells. So here you can see the formula is equal 6.24% divided by 52. That way, when you're watching the video, the question I always get in class is, what did you do in B3? What did you do in B3? Well, you can see it right next to the formula. Just so you get used to my approach in doing these. The next one is time. Well, here he says he's going to do this over 5 years. He wants to invest for 5 years. So do we equal 5 for 5 years? But he's not actually investing for 5 years. He's investing 52 weeks a year for 5 years. So here he's going to take 5 times 52 weeks. He's actually going to invest for 260 weeks. So he's going to take equal 5 times 52. The next one is his target. What is he saving for? How much money does he want? Well, you can see if he bought the car today, it was cost him $28,000, but he's buying the car in 5 years, and he thinks car prices are going to go up 2.5%. I don't know where he got that number from. If you go to the Department of Labor Statistics, they will give you inflation rates historically for about anything you can think of. If you want to know what pork prices have gone up or hamburger meat prices have done the last 30 years, the Department of Labor Statistics will give you that. So he may have gone to that site and looked at the cost of car prices and seen what they've done, and he thought, wow, 2.5% is a good forecast. I don't know what he forecast, how he got that forecast, but that's his number. So you can see he said the car today has cost $28,000, but in 5 years, we're going to use this formula number 2. We're going to take the present value, $28,000, times open parentheses, that's shift 9, times 1 plus my rate. My rate is 2.5% inflation. Now here, when you're inflating something and forecasting it, you do not need to adjust for weekly versus annual, just use annual numbers. And so I close that, and do shift 6 for 5 years, close that parentheses. And here I'm going to format it by clicking on the dollar sign and going 2 decimal places. So I'm going to have to expand out my column a little bit. So it's showing it as 31,679.43. It actually goes out a lot more decimal places than that, but I encourage you not to use the round function, to let it be unrounded. It just works a lot better for these problems. So let me copy that formula over so you can see what I did. And again, you notice I'm using 2.5% and 5. I'm not dividing 2.5% by 52. I'm not raising it to the 260. I'm just doing it. I encourage you just do it on an annual basis. So he needs to have $31,679.43 saved in 5 years so that he can buy a car for cash. So now we need to do our two factors. In this problem, we need the future value problem, but that's fine. We're going to put both formulas in here. There's the formula. So let me type this formula in B6. I'm going to do equal and use the exact same parentheses I used, except for don't use the different types of parentheses. I use brackets and other things. Always use the shift 9 and the shift 0. So if I have 1 parentheses, use 1 parentheses. If I have 2, use 2. So here I'm going to do equal parentheses 1 minus 1 divided by open parentheses, plus my rate. You want to actually go up and click on the rate so it says B3. I'm sorry, let me adjust that. Divided by 1 plus, I missed my 1 there, plus B3, close parentheses once, shift 6 to raise it, the exponent, raise it to the n, there's my n, is 260, close parentheses twice, divided by my I, and we know we do it correctly. If I get something on present value, you should get something less than 260. So if I hit enter, I should get something less than 260, and sure enough, I did. And I'm going to go up to my decimals, and I'm going to reduce my decimals. So here you want it to go to the right. We generally, for present value factors and future value factors, we usually go out 4 decimal places. You might remember this from your accounting class. If you use the table, the tables always go out 4 decimal places. Why? Well, when we're dealing with dollars and cents, 4 decimal places usually gets you a number that's close enough so you don't have rounding issues. So let me put that formula over there so you can see it, but you can see I'm doing exactly what I did in formula number 5, except for instead of actually using the rate or using the n, I reference those cells, B3 and B4. I'm going to do the same thing with the future value. I'm going to do equal open parentheses, formula number 6, 1 plus my rate, so B3, close parentheses, shift 6 to raise it the time, minus 1, close parentheses, divided by the rate, hit enter, and if I did it correctly, I'll get a number greater than my time. Let me copy that over. You do not need to copy over the formulas like I'm doing. I'm just doing that for your benefit so you can see them. So you can see exactly how I did that. It's extremely important that you reference B3 and B4 and you don't type in those numbers, because the next problem, the rate will change and the time will change. And so you want to make sure that you don't have it keyed as 1 plus 0.0012, because then you'll have to adjust that every time you do it. That's the beauty of Excel. Again, use your own formatting. So what some people like to do on the formatting is, if it's a number you enter, use a color that lets you know it's a number you enter. So maybe green means you enter a number, and everything else is a formula that you don't want to adjust. All right, down here we're going to do our table. Now the tables are going to follow a very similar format, whether it is a present value or future value problem. What we want to actually do is show the entire investment schedule that we're going to do from the very beginning. And so here's the columns we want to do. I'm going to start in A10. My first column is going to be time. Then in B9, we're going to type beginning, and then B10 value, beginning value. And C10, we're going to type our investment. How much are we going to invest? In D9, we're going to do interest, and in D10, we'll do earned. And my last, in E9, I'm going to do ending value. I'm going to go back up, and I'm going to hit my shift key and my arrow key. I'm going to highlight all of these. I'm going to center them. There's a center button up here at the top. I'm going to hit bold. And again, format it so it looks nice and professional. I like to use blue for my background and white for my colors, but do something that gives me your distinctive, what colors you like, make it look professional. All right, so on time, my time starts with period 1, so I'm just going to type a 1 there. My beginning value, this is a future value problem. When you have a future value problem, you're going to start with 0 because we haven't invested any yet. And then my investment, let's look at the investment. You notice on the investment, it says that my investment equals my future value, which is my target. That's what we're trying to save our, divided by my future value interest factor and annuity. So in C11, I'm going to do equal my target amount, which is in B5, divided by my future value interest factor of an annuity. I just hit enter, and I'm going to actually, Bill Gates, who does Microsoft Excel, he assumed you wanted dollar amounts because that's what the target was, but he, for some reason, gave you 4 decimal places. I'm going to reduce that to 2 decimal places because that's all we need. So there's my investment. Now in this formula, I'm going to have to put it over to the side. So I'm going to shrink column F. So you can see this. So in column C, there's my formula for column C. You don't need to type this over here. This is just for your benefit. So in column C, I have B5, which is my target portfolio, divided by B7. Sorry about that. Then my interest earned. My interest earned is always going to be the same formula. It doesn't matter if this is a future value or beginning value. My interest earned, except for with the present value, it's going to be interest expense. With future value, it's going to be interest earned. I'm going to take my beginning value, which is in B11, times my rate, B3. Now we always want to reference B3, so what we're going to do is on B3, we're going to put a $sign next to the B and a $sign next to the 3. That's what we call anchoring it in. That way when we copy this formula down, it will go down to each cell, beginning balance on row 11, then on 12, then 13. So we'll always be referencing the new beginning balance, but we always want to use the 0.12%, so we want to anchor that in. Now obviously the interest earned is going to be 0 because we didn't have a beginning balance. I'm going to format it for dollars and 2 decimal places. If you hit the $sign, it usually just automatically does 2 decimal places. All right, so let me copy that formula over. And that is going to be column D, what I did in column D. I rarely get phone calls, but obviously when I do a class video, I get phone calls. All right, let's do beginning value. I'll click on the $sign there. So what is my ending value? My ending value is just equal. We're going to take all of this as my money. So that's the advantage of me investing this myself, is I get to keep all the money. So I just take beginning value plus the investment plus the interest earned. You just add everything together, and that's my ending value. Here it's just what I invested. One thing, you probably had this in your investment class, in your accounting class. The present value and future value of annuity equations, they assume any investment you do happens at the end of the period. So what this assumes is that your first investment was not at the beginning of week 1, but at the end of week 1. That's why you didn't earn any investment earnings. Now, your accounting class, Mata talked about a future value interest factor of annuity due. Annuity due means you invest at the beginning of period. We're not going to do that. We're going to keep it simple and use the basic formula and just assume all of our investments happen at the start at the end of the first period and then 1 period after that each time. All right, so I hope this works for you. Let's go to time 2. For time 2, what we're going to do is do equal A11 plus 1. A11 plus 1, so we get time 2. I'll put that over on the side. That's column A. Our beginning value here, which we just do equal. You'll notice sometimes I do the plus sign. That's my habit. You can hit the plus sign or the equal sign. I prefer using the plus sign because it's just more convenient for me, but it doesn't really matter. And just go over, and you want to click on your ending value. Your beginning value at time 0 is your ending value from time 1. Your beginning value time 2 is your ending value from time 1. Just do equal that and hit equal. Now I'm running out of columns, so you'll just have to know that on your own. I can't type that one anywhere. So in column B, in cell B12, you want to do equal E11. Your investment, all you could do in the investment, you just do equal C11. So in C12, just do equal C11. So B12 equal E11, C12 is equal C11. So E11 and C11. For your interest earned, all you got to do is go up to D11, and all you got to do is just copy that down. You just bring that formula down. You'll notice when we do that, now here it's doing the beginning value, 103.90, but it's still multiplying it by 0.12%. Why? Because we put those $signs in. The ending value, we can do the same thing. We can just copy it down, just pull it down. You see that little square on the end? See how you get that plus sign? So if you just go there and just drag it down, it will give you the formula. All right, so now what we want to do is we want to drag this whole thing. So highlight this whole thing, and we need to go down to 260 rows. So if row 10 would be essentially times 0, then row 260 should be, time 260 should be on row, I think, 270. So what we're going to do is take this, we're going to drag it down, and we're going to try our best to go down to row 270. So don't go too fast. Let's go down to 270. You just drag it down. You'll have to take your column E and expand it out. And you see there, our last row is 260. You can see our beginning balance is getting really large. Our investment's the same. Our interest earnings is getting really large. And our ending value is 31,679.43. Now, how do we get back up to the top? Well, you could drag it up with this one thing I think I want to show you here. You have a control button on your computer, and you should also have a home key, H-O-M-E. If you just hold the control button and hit your home button, it takes you back up to the top. And then you can see we got 31,679.43. If you go back over the column E11, now you can do your control button and hit your down arrow, and it will take you down to the bottom. And you can do the same thing, control, with your up button. Get in the habit of using that control button to get you around a spreadsheet. You want to actually avoid using the mouse as much as possible. And so here we have everything put together, and our ending portfolio gets exactly the 31,679.43. When you do other problems, you'll do the exact same thing, except for some problems may not be 260 months. It might be 500 months or 100 months. So you'll just have to adjust this down here. But you can essentially, for the next future value problem, you can just come down here and do a copy, and just copy this. Or even better, you just take this entire thing, click on this little triangle up here, do Control-C the copy, and just take it to another cell and just hit enter, and you'll have it all set up. So I'm not going to do that for problem set 2. I'm going to start from scratch again. So I'm going to stop it here. We're actually going to do 2 videos. I don't want these videos to go too long. So the next video I'll do problem set 2, problem 2, and which is a present value problem. So that's it for the future value. Hopefully you followed all of that and you're getting 31,679.43 in that very last cell.